All right, so related to binomial distribution, let's now talk about binomial tree for stock prices. So next topic is binomial tree for stock prices. All right, so let's say that we are told that the stock price is today, let's say S denotes the stock. So the stock price today is $20. All right, so the stock price today is $20. And we are also told that the stock price could either go up or go down. The reason why it's called binomial tree is because we make an assumption that the price would either go up or would go down. So the stock price can take only two possible outcomes over time. So that's why, since we have two possible outcomes, the probability of up move is around 60%. And let's say we're also told that the probability of down move is around 40%. In addition to this, we are also given the up factor. What is the up factor? It's the speed at which the price would go up, which is around 1.12. So the price will actually compound at 1.12. Or if the price will also go down. So what will be the down factor? The down factor could actually be calculated as a reciprocal of the up factor. So the down factor is just simply going to be this reciprocal of the up factor. So if we take the reciprocal of the up factor, that's around 0.892. With all this given information in hand, now we have to construct a binomial tree, and this is how we could construct. The price today is $20. We said it could go up or it could go down. And if it goes up, it will grow at a speed of 1.12. So we'll say 20 multiplied by 1.12, and the price can actually be 22.40, or it can go down. So we could say 20 multiplied by 0.892, and the price could actually become 17.86. The probability of up is around 60%, and of course the probability of down is 40%. So after 1 year, this is what could happen to the stock prices. It's binomial, only two outcomes. Now again, in year 2, what can happen? It can either go up again from here. What could happen is it could go up or it could come down. If it goes up, we would say it's going to be 22.4 into 1.12. So it goes up at a speed of 1.12 to become 25.09, or it will be 22.4 times the down factor because it's coming down, and that equals around $20. Again, it could go up or it could go down from this scenario. If it goes up, it's going to be 17.86 compounded at 1.12. You get $20. So you have a common stock price here, right? Or it could come down further, which is 17.86 times 0.892, which is the down factor, and that gives us 15.94. Notice the same answer. If I want to find the stock price with two up moves, it goes up and then goes up quickly in one shot, here is what we could do. We could have got the answer 25.09 in this way. So from $20, it grows at a speed of 1.12 in the first year, further goes at 1.12 to become 25.09. Alternatively, this $20 could have been calculated in the first year. We are going up, as you can see, at 1.12, that's up factor. And then in the second year, we go down at 0.892, which will give us around $20. So that's how you could also calculate the prices at each node of the tree. All right, having discussed the binomial tree, we now talk about the continuous uniform distribution. We spoke about discrete. We are done with discrete. I would just like to go back to this slide that you see. We spoke about discrete uniform, and we also spoke about binomial distribution. Now we are going to talk about two types of continuous distributions. And we know continuous random variable is a variable that can take on uncountable number of outcomes. And we said stock returns are an example of that. So we have two types of distributions here. We have continuous uniform distribution as before. We said the probability of, here for discrete uniform, we said the probability of each and every countable outcome is equal. While under continuous uniform distribution, the probability of all outcomes, but the outcomes are not countable, is equal, right? But can we count the number of outcomes? No. So the data is uniformly distributed. That's how it would generally actually be. On the other hand, we have another type of distribution which is called normal distribution. So in a continuous uniform distribution, you will have an upper and a lower limit. So you'll have a kind of a data in which there is an upper limit and a lower limit. However, the outcomes cannot be counted despite of the limits, because you cannot count the number of outcomes. You have continuous outcomes. So let's discuss continuous uniform distribution in more detail. We'll look at it here. So that's our continuous uniform distribution. As we said, basically it's a distribution which is actually defined over a range that spans between an upper limit and a lower limit. So you have, you can find two sets of probabilities. You can find the probability of X, which is the probability of outcome X, and you can also find the cumulative probability of X. Now, if I look at this example where we have been given the limits, you can see stock returns span between minus 10% to plus 10%. So what we know are on any given day, assuming continuous uniform distribution, calculate the probability of returns falling between 5 and 10%. So if you notice, we have been told that our return actually spans between minus 10 to plus 10%, right? That's our upper and lower limit of our data. Now you may think, while we have an upper limit and lower limit, why is this a continuous random variable? Because even though you have the limits, but you can still not count the number of outcomes that can happen between minus 10 and plus 10. For example, you can have an outcome that is 7.77. There could be another outcome that is 7.771. Then there could be another outcome which could be 7.778. And each of these are actually unique. Hence, you cannot count the number of outcomes that you can have between the two upper and the lower limits of your overall data or your distribution. All right, now, if we ask, given this, let's try and answer the first type of a question, which is, what is the probability of having an X value, or what is the probability of getting 6%? Since it's uniformly distributed, it's equally distributed, the data is uniformly distributed, and if you plot it, this is how it would look like. It's completely uniformly distributed, right? The probability, this is how it would actually be. So what is the probability of getting exactly 6%? 6% is one outcome, one out of uncountable, because you don't know how many outcomes are there. Since the number of outcomes are uncountable, therefore the probability will be 0. So probability of a specific outcome X, in other words, the probability of X in a continuous distribution will always equal 0. I'll repeat again, the probability of getting outcome, let's say X, whatever is X, is, as you see in this case, is 6%, will always be 0. What is the probability of getting above 10? That's another question. What is the probability that X could be more than 10%? Since the upper limit in your data is 10%, that means you can't have an outcome more than 10%. Therefore, it will be 0. What is the probability of getting an X less than minus 10? On that side, you can't get any outcome. Again, that's also 0. However, you can calculate a cumulative probability. So you might say, for example, as you see the question right here in this example, calculate the probability of returns falling between 5 and 10%. So you want to find the probability that returns will lie between 5 to 10%. So here's how you could look at it. If you look at the range of your entire data, range is basically calculated as the difference between highest minus lowest. So that will be 10 minus 10. The range of your entire data is around 20 units. But we want to find the probability of a return between 5 to 10. So between 5 to 10. Now, if we get the range of our interval, which is between 5 to 10, the range of interval will be 10 minus 5, which is equal to, the range is 5 units. Now, how can we find the probability that a return could fall between 5 to 10, which is a cumulative probability, out of a total range of 20? Well, all we do is simply, for this question, let's say this is our question number 2, this is number 3, and say this one, the one we are answering right now, is number 4, which is probability of getting an answer between 5 to 10. All you could do is you can find this probability as you can divide the range of your interval, which was 5, by the range of the entire data. So the range of your interval is around 5 out of a total range of 20, and that gives us around 25% of data, right? This covers around 25%. Put it the other way, if we divide data uniformly into equal sizes, you would say from 0 to 5, you can have 4 intervals, right? From minus 10 to minus 5, and from minus 5 to 0. So 1, 2, 3, 4. So you have 4 intervals of equal sizes, and the probability of getting return in one interval out of 4 will be 1 over 4, which is actually 25%. That's also how you could look at it. Or you could just simply remember how you can get the answer in this way, whereby you can divide the range of the interval by the range of your entire data, and that should give you the cumulative probability when you have a continuously uniform distribution. So make sure you remember that the probability function, or the probability of outcome X in a continuous uniform distribution, will always equal to 0. All right, we can now move on to the next type of distribution, which is actually normal distribution. So let's talk about normal distribution now. This is a kind of a distribution that is also continuous. And as we discussed before, this is a kind of a distribution that has a bell shape, and it would generally look like this, where the data is actually uniformly distributed on both on the side of the mean. And it plays key role in the modern portfolio theory and in the risk management techniques as well. So the idea is that if you have a large distribution of data, then most likely it will have this shape. The data distribution would be like this. So most of your data would be centered around the mean, and some of your data would be to the left side. These will be your outliers, and to the right side of the mean. As you can see, you can have infinite outcomes, both to the left and right. That's why it's a continuous distribution, or a continuous random variable. We did talk about the properties of normal distribution, and we said it's completely described by its mean, by the mean of the normal distribution, which is mu, and variance, which is sigma squared. And normal distribution will generally be symmetrically distributed around the mean, which means equally distributed, such that the skewness is 0. It's not skewed. So the skewness is 0, and kurtosis, which represents the height and the amount of weight in the tails, is generally, we know that it is actually 3. We also know that approximately 68% of the data, 68% of data falls between plus minus 1 deviation. So around 68% of the data will always fall between -1 to +1. So if this is -1 deviation, and let's say this is +1 deviation, so in between these two number of deviations, you'll have around 68% of the data. Around approximately 95% of data falls between ±2 deviation and around 99% of the data falls between plus minus 3 deviations. So 3 is wider. With wider number of deviations, most likely more data would fall. I hope you can recall this. We discussed before as well. 3 here represents the number of deviation, and this represents the size of each deviation. All right, so let's look at an example to understand this further. Say we have a normal distribution, which is completely described by its mean. Let's say the mean is actually 30. And let's also say that the deviation, we are given the deviation, standard deviation is around 5%. And what we are actually looking to do is we want to find probability, so we want to find the probability that let's say a random variable x will have a value below find the probability that x will be below 40%. So what is the probability that x will be below 40%? So this is how we could actually look at it. What we are saying is, this is how a data is actually distributed. The mean is around 30, and we want to find what is the probability that the x, a random variable x, will have a value below 40%. So we want to find this. What is the probability? The probability lies to the left of 40. As a first step to answer this question, our first step would be, so this is our question. The first step would be to actually find, we have to standardize this. So what has happened is, we have a normal distribution table whereby we can enter standardized value of the normal distribution to try and find the probability, or to try and find the percentage of data that falls below the standard numbers. So we can use the normal distribution table, which is also called Z table, whereby, I repeat, what we have been given is, we are given that below certain standard values, a certain percentage of the data falls, or a certain probability happens, and that probabilities are given to us for standard values. So as a first step, we need to standardize our distribution, or we'll have to standardize the variable x. By that, I mean, so let's say we standardize x. What I mean by that is, let's put it this way. If I were to ask you, how many times has 40 deviated from 30%? If the answer was, how much did 40 deviate from 30, you would say, from the mean 30, you would say around 10%. But if you look at the size of each deviation, that's around 5. That means, to answer my question, how many times has 40 deviated, you will say from 30 it deviated once and then twice, right? 2 times. And how can we get that? We would say 40 minus 30, this gives us the total amount of deviation, and we divide that by average deviation of around 5% to give us 2 deviation. And the way it's calculated is, we say x, which is the random variable x, which is 40, minus mu divided by deviation, divided by the standard deviation, and this gives you the standardized value, which is actually called score. The score can be interpreted as number of deviations. In other words, here is what we are actually saying. We are saying that 40 is equivalent to plus 2 deviation. So your random variable x, 40, taking a value of 40, is equivalent to plus 2 deviation, while 30 does not deviate, so this is equivalent to 0 deviation. So 30 is equivalent to 0 deviation, while 40 is equivalent to 2 deviation. And as I told you earlier, once we have the standardized value, we can always get the percentage of data that falls below that standardized value, which is the score. Or you may also call that as probability. So step 2 would be to use the table, the standard table, or the normal distribution table, which is also called Z table. So use Z table to find probability. And let me show you how you will actually use the table. All right, so we go to the table. Here's the table, and this would be given to you in the textbook in the appendices section. So if you see to the left side on the first column, you are given a Z-score, and you will see up to two decimals. You will see basically a 1 decimal number here. For example, you will find 1.1 here, and the second decimal would actually be read from the very top from the first row. So if it's 1.15, you will look for 1.1 here, and you will look for 5 from here, and this will actually be the probability if that is your score. Likewise, if the score was 1.55, you will read 1.5 from the first column and 5 from the first row. So that's going to be right here, right? But if we go back, the score that we got was 2 deviations. So this is equivalent to 2, and we need to look for 2.0. And 2.0 is right here. This is 2.0 right here. That means 97.72% of your data falls below 2 deviations. All right, so the answer would be the probability that X will be less than 40% is equal to 97.72%. In other words, here is what we are saying. If X is 40, the probability that it will be less than 40 is 97.72%. Had the question been, what is the probability that X will be more than 40? We would follow the same step in the first step. We will standardize, we'll look for 2. But now, keep in mind that the normal distribution table always gives you probability to the left of the score. So if this is your score, it will always give you probability on the left side, never on the right side. So this 97.72% is to the left of the score. But if we want to the right side of the score, it's quite logical. You're just going to subtract this from 100. So you'll say 100 minus 97.72, and that gives you around 2.28%. So that's how you would actually answer. And make sure, again, you remember that the normal distribution table always gives you probability to the left side, never to the right side. Also, I would also like to add some more thing here. Let's say if I'm doing some calculation and I've done the first step, okay, and my score is around let's say 0.45. All right, so let's say my score, say the score is 0.45. And as you see, it's a positive score. The score to the right side of the mean will always, if this is the mean, the score this side will always be positive. So the score is 0.45. And I want to find the probability below 0.45. So let me show to you what can happen in the exam. Firstly, in the exam, they never give you such a long table. They just give you a very small table right in the question itself. And let's look at this table. Notice here I've given you 2 tables. If you see a normal distribution table in the textbook, you will find it spread over 2 pages. And of course, this isn't complete. But if you look at the appendix section, and you will find the full complete table. Here I have just snipped this part for you. But if you look at a normal distribution, here is how normal distribution is. To the right side of the mean, you'll have 50% of the data. So 50% of the data is spread on that side, and 50% of the data would actually be spread to the left side. That's number 1. Number 2, the scores that lie to the left side would be negative. So the scores here will all be negative, while the scores on the right side would all actually be positive. For example, if in our example here, X was 20%, so the formula we would use is 20 minus 30 divided by 5, and we would get minus 2 deviation, which would fall to the left of the mean. So the scores on the left side are negative and the scores on the positive side are actually positive. If you look at the table here, on one page of the textbook, you will find a positive score table. On the other page, you will find a negative score table. You can see here positive scores and negative scores. And if you notice, in the negative table, the data would be, from 0%, here you have 0% data all the way up to 50% data, right? Here is what we are saying. We are saying from 0% all the way up to 50% data. That's exactly what you see. If you see the last thing in the table here, if it's a complete table, you'll find a 0 right here. So if you look at the probability of the numbers, they're growing from 0 all the way up to 50%. So right here, when you come to 0 deviation, it's 50% of the data. And then in a positive score table, you'll have the rest of the 50%. So the rest of the 50% from 50 all the way up to 100%. And that's what you see here, right? If you see the positive table, starts from 50, keeps increasing, and all the way somewhere down there, it will become 100%. So first thing, you need to understand this basic stuff about the normal distribution table. The second key thing you need to understand is, going back to the example I was telling you about, if our score is 0.45, it's a positive 0.45 score, and we want to find the probability of below 0.45. How can we find the probability? Okay, firstly, so here's what I'm looking for, okay? What we are looking for is, I want to find a probability below 0.45 deviations, which is my score. And I'll just, if I'm given a positive table in the exam, so if you're given a positive side table, and that's exactly what we're looking for, positive side. So we want this below this. If you notice, we have 0.4 here and 5 right here. So this is 0.45. That means 67%, approximately 67.36% of your data falls below 0.45 deviation. However, it might happen that we have calculated the score to be 0.45, but we are given a negative table in the exam. So how are you going to deal with that? So if you're given a negative table, here's what you need to understand. And I always say in simple, here's what you could do. What you require, let's look for what we require. Let's draw that. What we require is the percentage of data or the probability below 0.45 deviation. So we want this. We want this side, which is a big side. But what we are given, let's see what are we given. We are given the table. If we look for 0.45 in this table, that will come to the left side, if you notice, right? 0.45 right here. So minus 0.45, we have minus 0.45. So it will give us the probability below this, below minus 0.45. If you notice, the small side right here would equate to the small side here, while the big side right here would equate to the big side right there, right? So how much would fall below minus 0.45? The answer is around 32.64%. So this is around 32.6% of your data would fall below minus 0.45. But that's not our answer if you're looking for the probability of below plus 0.45. If we subtract this from 100, we will get that this side is 67.36. And this side actually equates to what we want, which is 67.36, because the larger side would equate to the large side right here. Or simply what you could do is, if they give you, if you have a positive score, you want to find the probability below the positive score, while they give you a negative table, just simply subtract 1 from it and you should actually get your answer. But you could just understand this in more detail in this way. We can now move to an example, and let's look at this example. So assume the portfolio mean return is 12% and the standard deviation of return estimate is 22% per year. You want to calculate the following probabilities. Assuming that a normal distribution describes returns, you can use the excerpt from the table of the normal probabilities to answer these questions. What is the probability that portfolio return will exceed 20%, meaning will be above 20%? So it's not like the previous question where we looked at what is the probability that X will be below 40%. But the steps should be the same. As a first step, we'll actually standardize, and then we'll use the table which will give us the probability below 20%. So first thing first, your mean return here is around 12%. So the portfolio mean is around 12%, and the deviation is 22%, right? So we are given both of these, and X is actually 20%. So if we standardize, if we do that as a first step, we would say X minus mu over deviation, which is 20% minus 12% divided by 22. And that gives you approximately, if we round it off, it's 0.36. So we want to find, what we are looking to answer is our mean was 12, and we want to find the probability above 20%, right? Which equates to 0.36 deviations. Keep in mind the table, if we look for 0.36 in the positive table, if we look for 0.36 in the positive table, it will give us the probability to the left of 0.36. So let's look for 0.36, 0.36, which is 0.3 and 6 right here. It will give us to the left side, and this is around 64.06%. But we don't want to find the probability that the portfolio return will fall below 20%, rather above 20%. So we will have to subtract from 100 64%, and this will give us the probability on this side, which is around 35.94%. That's the answer. If you subtract from 100 64.06, you should get the answer. All right, we go to the next question. What is the probability that the portfolio return will be between 12% and 20%? Right, so let's answer the second question. Here's what we are being told. 12 is our mean. And what is the probability that it will be between 12 and 20%? So between 12 and 20, we are looking for this part. Now, here's what you're going to do. As a first step, you will standardize 12 using this formula. That will be your first step. Then you will standardize 20. And if you do standardize 12, how many times has 12 deviated from 12? The answer will be 0 deviation, right? I mean, you can try and use the formula. If you use the formula, it will be 12 minus 12 divided by 22, which is 0 deviations. It does not deviate. And we already know how many times has 20 deviated from 12, and that's about plus 0.36 deviation. So once we standardize, we can use the table to find the probability to the left side of the scores. And without mentioning, we know the probability that would lie to the left of 0 deviation. How much data lies? We know it's 50%. And you can prove that by looking for either of the two tables. Look for 0 deviation, 50% of the data falls. Right, so 50% of your data falls to the left side of 0 deviation. How much data falls below 0.36 deviation? Which we already calculated. We can look at it again, 0.36, around 64%. Now the question is, if 64% of the data fall below 0.36 and deviations, and 50% of the data falls below 0 deviation, how much data falls between 0 deviation and 0.36 deviation? Think about it. Of course, it's going to be the difference between 64 and 50%. So the answer will be 64 minus 50. That's around 14% of the data will fall between 0 and 0.36 deviation, or between 12 and 20%. So first, if I were to show you the steps, I'll show you the steps on this side. We'll say step 1, standardize both variables. So you need to standardize the variable 12 and 20. Step 2, find probability of both using table. And step 3, find the difference between the two. And that's how we actually, between the two probabilities. That's how we got our answer, which was 64 minus 50% equals 14%. So this is how you do the calculation for a normal distribution. Let us now see the application of the normal distribution. So we'll now talk about application of normal distribution. So let's say that an investor wants to invest $1 million. So the amount of investment that the investor wants to make is $1 million. And the investor wants to withdraw 30,000 from this investment after 1 year, such that the size of the investment should remain $1 million after 1 year. So how much does the investor want to withdraw after 1 year? Is 30,000, such that the value of the investment should remain 1 million after withdrawal after 1 year, which means the minimum return that the investor is looking for in dollar terms is around $30,000. So if we find the minimum return in percentage terms, because he wants to withdraw 30,000 such that 1 million remains 1 million, he is looking to earn 30,000 out of 1 million on 1 million, that's around 3%. So let's say RL represents the minimum return that the investor is actually looking for. And let's say there are two funds that the investor wants to choose from to see which fund is more safer or less riskier in terms of achieving the minimum return. So let us look at the two funds. And here we have, let's say, the data about the fund. We have two funds, Fund A and Fund B. We know the mean return of the fund. Let's say the mean return of Fund A is around 5%, while the mean return of Fund B is around 8%. And we also know deviation, which we know is a measure of risk. We know the deviation of Fund A is around, say, around 12, while the deviation of Fund B is around 18. Okay. Now, with all this information that we have been given, we want to find which fund is more safer for this particular investor to invest in terms of achieving the minimum return or minimum rate of return. To answer that, we could look at a ratio whereby we compare the return against the risk, and the fund that gives us the higher return per unit of risk should be more safer. So let's look at something called safety first ratio, or in short, your SF ratio, which compares the return of the portfolio or the fund against the risk. But of course, you're going to compare the excess return. This is return on portfolio minus the risk-free rate, which gives you the excess return you earned for taking risk, and you divide this by the risk, which is deviation. So the interpretation is, this is Sharpe ratio. For safety first ratio, you will just take the excess over and above the minimum return. Small correction here. You'll say RP minus RL, which will give you the excess return over and above the minimum return per unit of risk by dividing it by the risk. So if we do the calculation for Fund A, we will just simply say 5 minus 3 divided by 12, right? So that will give us the safety first ratio for Fund A. So that's around, if we see, that's around 0.16. 0.16. So if I write the SF ratio here, this is around 0.16. If we do the same calculation for B, we would say 8 minus 3 divided by 18. So let's say, what answer do we get? This is around 0.27. Now you can see clearly which fund is better. Of course, the one with the higher safety first ratio, right? High safety first ratio means the excess return per unit of risk is higher, which means it's more safer or simply less riskier. So which fund is more safer in terms of safety of earning the minimum return? It will actually be fund B that has a higher safety first ratio. Now this could lead to a related question, which is, we know that fund B is safer, but what is the probability of fund B falling below minimum return, which is RL? We already know that fund B will have a lower probability of falling below the minimum return, while fund A will have a higher probability because of lower safety first ratio. All right, the first step would be, let's understand what's happening here. Your mean return would be here for fund B. Mean return is around 8%, while the minimum return lies to the left side, right? This is your RL, the 3%, as you can see. And we want to find the probability of it falling below the minimum return. Clearly, if I ask you, if you standardize 3%, what will be the score? Will the score be positive or negative? Of course, since it lies to the left side of the mean, the score should be negative. And the formula we used was, we always used to say x minus mean divided by deviation. So here's what we would do. If we want to find the score, we would do 3 minus 8, which 3 is our x in this case, divided by the deviation. Deviation is actually 18. So if you notice, this is exactly the same formula that we are using for the score as we are using for the safety first ratio. Although I did not write the safety first ratio for B, so let me write that for B so that you can clearly see it. It will be, again, RP minus RL over deviation. So if I show you the numbers, it will be 8 minus 3 divided by 18, and you should get 0.27. So the formula is quite similar for the score as is for the safety first ratio. However, in the safety first ratio, we write the formula as return on portfolio or the fund minus the minimum return. While for the score, we are writing the variable x minus the mean return divided by the deviation. So if you were asked this question, you would either have to get the score again yourself, or which will give you minus 0.27, or if you are given a safety first ratio, or if you have already calculated a safety first ratio, as in our case, you just simply put negative sign with SF ratio. And I hope by now you understand why you have to do that. Your score, this safety first ratio is exactly like a score, but this score would lie to the left side, which means it will be 0.27 minus here. Therefore, you need to put a negative sign. And once you put the negative sign, this is your first step. Your step 2 is to actually use table to get result, to get probability. And we just need to go back and look for 0.27. Let's look for 0.2. Here's 0.2, and 7 is around here. So 60% chance. So the probability is 60.64% chance compared, is the probability that fund B will fall below the minimum return. If we look for fund A, which is 0.16, it will certainly have higher probability. 0.16 All right, I just realized a small correction here. By mistake, I looked for it in the positive table while we had a negative score. So we were supposed to look for it in the negative table, or we would have to subtract 1 from the result that we got here. So I'll just make a correction going back. So it's not 60.64. You'll have to subtract this from 100, or let's go to the negative table. 0.27 in the negative table minus 0.27 is right here, which is 39% probability. So this will be around 39.36%. On the other hand, if we look for fund A with minus 0.16, if we look for minus 0.16, notice the probability is higher, which is around 43.644 fund A, which has a higher probability of falling below the minimum return. So just to sum up, if we were looking at a positive table with a negative score, of course, we would have to do 1 minus that number to get our correct answer.